London! How are you? All awake? Are you ready to kick off the first NDC conference of this year? Yep. Awesome. Well, I'm actually a little bit annoyed at this year, 2024, because I'm actually celebrating a milestone birthday this year. You know, one of those pretty round numbers. I'm basically approaching the age where people just put a single sparkler on your cake because, you know, one per year, that's getting way too cumbersome. And to be honest, it's almost a fire hazard at this point. So I felt that that's good enough reason to have a first midlife crisis, don't you agree? And apart from all of the expensive bags and shoes that entails, it's also really been a time of deep reflection, of thinking back on my life, on my career, and thinking of all the good things I've been through, all of the successes, but also all of the failures. And more importantly, what I've learned going through all of those experiences and what that's taught me. And that's exactly what I want to share with you here today, is, you know, some of those deeper insights that I gained over the years that I truly believe made me way better at my job. Now, to do that, I need to take you all the way back to one of the first projects that I was working on in my career. Basically, you could think of it as a sort of proof of concept. We were very early on, still a little bit of insecurity on whether the customer was going to sign with us. So we just quickly cobbled together a couple of working use cases to make sure that they would sign in. We didn't think this through. We weren't, you know, thinking about architecture or the right technology. We just, you know, quick and dirty. Let's get this working. And I remember joining that meeting with our team and also a sales representative and a project manager. And the demo gods were with us. Like, everything went flawlessly. And the customer was like, wow, this is exactly what I need. This is awesome. When can I use this? I remember locking eyes with the sales representative for a split second before he turned away and said, well, as you can see, this is already operable. Give us a couple of weeks to figure things out, and you'll be ready to go. Customer, super happy. Me, lightning bolts shooting from my eyes. I mean, you can pretty much guess what happened, right? We were basically going to production with something that wasn't ready and building feature upon feature on a foundation that was never meant to support the scale at which it was being used. And the thing is, it was really hard for us to get additional budget to fix this because in their eyes, everything worked. Everything looks pretty. Everything looks good. Of course, that's true until it didn't. And things started to fail and the cracks started to show. So this project ended up failing. And I was like, oh my gosh, how did I get here? And more importantly, how do I never get here again? Now, at the time, I really attributed this failure to our technical choices. We should have really thought better about our architecture from the get-go. We should have really made the right choices from the beginning, and then this wouldn't have happened. So what did I do? Well, I studied. I immersed myself in all the latest and greatest technology, or you know what was latest and greatest at the time. And yeah, I really believe that by, you know, being aware of all of those frameworks and all of the language features and all of the framework features, I would be way better equipped to make better choices next time. And life goes on, so at some point the next project came along. And it was a dream. It was, you know, the developer's dream, greenfield. So what did I do? I treated it like a kid walking into a candy store with a Platinum American Express card. I used all the latest and greatest technology. Scalability, you bet. And, you know, unit testing, yep. Integration testing, yes. Acceptance testing, you got it. Performance testing, anything. Like, you name it. Like, clean code, really thought through architecture. And you might ask yourself, so did that then make it successful? No, because what happened is that we ran out of budget. We basically were so focused on doing everything perfectly right, and we were gold-plating, like beyond what you can believe, that we never even got to deliver a first functioning version to our users before they pulled the plug on us. And I really had a rough time with this one. Come on, how did I get here again? The thing is that I truly believe that this time I did everything right. You know, all of those best practices that I learned about, I applied them. All of those anti-patterns, I avoided them, right? So I was like, how did this happen? And I realized that I just wasn't considering all of the variables at play. So I felt that sting of disappointment for a while. Now, throughout my careers, I've also had the opportunity to work on a lot of successful projects. Thankfully, they didn't all end so dramatically, okay? But when I look back, even if I think of each individual thing I ever worked on, actually, every project had some friction, you know, had some different issues with them. And then basically what happened is that thought process of never do this again, and oh, never do that again, that basically swung back and forth a couple of times. And whenever something succeeded or failed, I took those learnings to the next project, to the next customer, to then implement that there. And what I found over the years is that actually some things that didn't work very well in one context actually ended up working exceptionally well in different contexts. And just like with the Newton's cradle, that back and forth started to stabilize over the year. And with that stabilizing cradle also came an eye-opening realization that there is no such thing as the right architecture. And there's also no such thing as the right set of frameworks to use to make you successful. There is no perfect programming language. And success wasn't also dependent on the team structure or composition alone. It also didn't have to do necessarily with the project methodology. And it also didn't really depend on the size of the organization. It was actually something deeper, something that actually most organizations, nobody ever paid any attention to. It was about the decisions that we made and how we made them, how much attention that we spent on that part. Now, all of us make decisions on a daily basis, right? It doesn't matter whether you're very early on in your career or whether you're a tech lead that's making decisions about large-scale applications. So with that in mind, ask yourself, over the last few weeks, as you were at work, what decisions did you make? And how impactful were those decisions? What were the negative effects of the decisions that you were making? Because there always are some. Is it something that would work in the long term, or was it more of a quick fix type of thing? And also, what problem were you really trying to solve? Like, did you really understand that problem well enough before you dove in? Also, is it a problem that needed to be solved right now? Did you consider maybe just postponing that for a while? And which solutions did you consider? Did you even consider multiple options? What assumptions did you make about the context that you found yourself in? And also, how did you ensure that you weren't overly biased towards your preferred solution? Can you clearly explain to me your thought process on why this is exactly the right way to move forward in your context? And did you take time to actually validate that thinking with others? In short, how are you debugging your thoughts? Now, if this is how you feel right now, no worries. That is something that we want to try to address right now, right? Because actually, over the last few years, I've been studying and practicing critical thinking quite a lot. And actually, it's been a process of sort of picking apart my own thoughts and really thinking things through. And that's exactly what I want to be talking about today. Now, debug your thinking. I didn't choose this title just because it's a nice play of words, although I'll admit it is. But the reason that I chose this specific title is because having studied and practiced critical thinking, I truly believe that many of the things that we need to do to think critically actually aligns really, really well with the way that we actually debug our systems when something goes wrong. Because when something goes wrong, what do? We'll take a moment and try to think about the problem that we're facing. What is going on right here? In which context does this occur, right? We'll also take a look at some of our observability signals, like traces, logs, and metrics, to get a sense of what is going on and where. Right? From there on, maybe we'll start debugging parts of our system to see, okay, what data is coming in and which order of operations are being executed. And that's usually where we start placing breakpoints, right? To make sure that we can also inspect certain variables and validate whether they do indeed carry the values that we think they do. And I actually found that many of these activities would actually be a really good exercise to apply to our own thought process. Now, you might be thinking, okay, great, there is no such thing as a mental debugger, right? But we can build one. Based on multiple practices and techniques, we can build our own mental debugger. But before we do that, we also need to be very aware of one of the traps that we tend to fall into. And that is our beloved solution mode. Because what usually happens is that someone walks up to your desk, or schedules a Zoom call. And then it's like, oh, Laila, I have this problem. Like, can you please fix this for me? And we immediately jump into solution mode. We immediately start thinking about, okay, how am I going to resolve this, right? But the thing is that that also carries dangers. We're basically biased towards jumping into that solution mode. And it's not only that. It's not just our fault, because when people come up to us and they say, hey, I really need you to fix this, they want it done by yesterday, right? So it's not only that we're biased towards solution mode, it's that we're incentivized to immediately jump in. But that carries risks, because if we haven't taken enough time to actually understand the problem, then we might be coming up with a solution that is not a good fit. Or even worse, we might be solving the wrong problem to begin with. And that is why it's so important for us to slow down and actually think about, what are we being presented with here? What are they telling us here? Like, is that actually a problem? Or is it maybe some friction that they're experiencing, a symptom that they're seeing, maybe something that they're observing, right? If it's not actually a problem, then we need to dig deeper. Because actually the most common thing that tends to happen is that people bring us solutions. Oh, I need a big red button over there. Or can you please add a little field over there on that, on that page? Or get me a report of that data, right? People bring us solutions. They don't generally come to us with problems. And that's why it's so important to dig a little bit deeper to try to understand what's going on. Now, there is one magical question that can help you with that. Why? ¿Por qué? علاش? لماذا? كيون? It doesn't matter which language that you choose to ask this question in, as long as you ask it and you do so repeatedly. Now, what I'm referring to is basically called the 5 whys techniques, which was introduced by Toyota, and it's a sort of root cause analysis technique that can help us dig a little bit further to understand what problem we're trying to solve. Now, there are many other root cause analysis techniques out there, but the reason that I'm mentioning this specific one and why I find this one valuable is because it's really simple, and we don't want to go in full analysis mode just yet. We just want to get an initial framing of that problem that we're trying to solve, right? So asking why or why not can actually be really helpful to get a sense of what are we trying to solve here. And together with this powerful question, you'll also need something else, a pencil or a keyboard, if you prefer. Now, first of all, this is important because writing things down is going to help us slow down just a little bit. It's going to force us to slow down, okay? But what you will also find, even if you just take 5 minutes to do this, is that it's actually incredibly hard to write down a problem statement. Why? Because writing is nature's way of letting you know how sloppy your thinking is. Because what's happening now is that you basically have to convert all of those chaotic streams of thought that are going on in your brain into something that is concise, specific, and understandable by everyone. And that means that you need to actually have a very good understanding of what you're dealing with, right? But it will also bring you benefits. Because once you have that problem statement written down, you can go to your peers and share it with them and discuss it with them and say, hey, let's talk about this problem. But even more importantly, you can take that to your stakeholders. Hey, are you sure this is the problem we should be solving? That can avoid us a lot of misunderstandings down the road as well, right? So, whenever you have that problem statement, a few key points for you to remember. First of all, write it down. Just a single paragraph, doesn't have to be a novel, okay? Also, stay clear of any solution proposals. At this point, we're just thinking about the problem. We don't want to get into solutions that are going to also limit our thinking later. Also, stay clear of technical terms. We tend to do that a lot, right? Kubernetes something. But usually, you don't need technical terms to actually describe a problem you're facing. Usually when you do that, you're still stuck in solution mode, and you're just trying to frame it a way that suits you. So be very mindful of that as well. Dig deeper. And finally, make it measurable. What do I mean by that? Well, what needs to be true in order for this problem to be solved? That's also a very good way of actually enabling anyone to understand the problem that's going on. But then when you have that initial problem framing, you look at it, and you should still ask yourself, is this the right problem to solve? Let's consider a very well-known use case around problem solving called the elevator problem. Now, in this case, there was actually a building manager that's getting a lot of complaints. You know, the elevator is so slow, it's taking me ages to get where I need to go. Your elevator is stopping at every single floor. Like, people are frustrated. So what happened is that this problem is framed as the elevator is too slow. Simple, concise, it's not a novel. Pretty good problem statement, right? But there's one big issue with the way that this is currently framed, because it's actually narrowing down and even self-imposing the applicable solution space. The elevator is too slow, so we need to make it faster, right? And actually, when this problem was presented to a group to solve this, they came up with options like, maybe we should improve the algorithm, or maybe we should upgrade the motor. I mean, how old is this elevator? Like, can't we just replace it? Which is the equivalent of a system rewrite, right? But what happened in this case study is that they actually reframed this problem to the wait time is annoying. And that actually had a very interesting consequence, because when this group was presented with that second problem statement, they came up with wildly different options. And actually, what they ended up doing to solve this problem is installing mirrors in the elevator. Why? Well, because people were now offered something incredibly fascinating to look at. Themselves, right? And people stopped actually complaining. And because people stopped complaining, you could argue that this was a sufficiently good solution to the problem, right? Now, what is done here is what is called reframing. And I think we should do it a whole lot more, starting with our own role in the industry. Because I've been in this industry for a while, and over the years, when people would ask me, so Laila, what is it that you do for a living? I would say, well, I'm a coder. I write code. I build complex systems, right? Now, I'm almost 2 decades into my career, and I think that that is the worst possible way that any one of us could think about our job, because it is putting us in completely the wrong frame of mind. We are not here to write code. We are not even here to build complex systems. We are here to solve business problems, right? And yes, usually that does involve the means of technology. But if we are faced with a problem that doesn't require like any letter of code to solve it, then why wouldn't we? It's actually our responsibility as technical experts to be able to identify and call out when we're faced with a problem that doesn't require a technical solution at all, no matter how much fun it would be to build. Now, I really believe that if we start thinking about our job in those terms, we solve business problems, that will also allow us to get much better at actually reframing the problems that we are faced with. So when you have a problem statement ready, ask yourself, is this statement even true? Like, is the elevator actually slow? Like, how fast are elevators, generally speaking? Also, who is affected by this? Right? Who are your stakeholders? In which way are they affected? That's a big part of understanding what the problem is to begin with. And also, in that problem framing, is there a solution bias in there? Right? I'm not talking about solution proposals, like I mentioned before, but rather a bias. It's still framed as a problem, but it's sort of pushing you towards a way. Like, the elevator is slow, so we need to make it faster. That's a clear solution bias. Okay? Also ask yourself, what actually happened before this friction occurred, right? Was there maybe maintenance done on the elevator? Or maybe a new company actually moved into the building and we're kind of over capacity without realizing it. And finally, ask yourself, in this problem statement, in that problem space, are there any hidden influences? Could it be that all of these complaints about the elevator are actually happening as a strategy to force the building manager to lower the rent? By asking yourself all of these questions, we can see whether we can reframe the problem and actually find a better problem to solve. So, as you can see with this use case, right, problem reframing can drastically impact the solutions that we end up coming up with. Just with that different perspective, just looking at things inside and out and upside down, before we go into solutions, see how much impact we can already create there, right? It's important to remember that a suboptimal solution to the right problem is so much better than a perfect solution to the wrong problem, okay? So, reframing is a sort of activity that you want to do continuously as you start analyzing the problem more deeply, as you start looking into multiple solutions, because as our sort of understanding of that problem grows, maybe we'll be able to actually reframe it to another problem statement at a later point as well. Okay, so now we've taken a moment, we've slowed down, we've thought about the problem that's being presented to us, and now we need to come up with solutions, right? And that's where we face a bunch of additional challenges. First of all, our bias towards speed. Let's just get this over with. Like, I was working on something really fun, and now you're coming to bother me with this problem, right? And that tends to go hand in hand with our bias towards the stuff that we already know, right? That's why so many companies are still using SQL Server to store JSON. Because, well, we already have the infrastructure, and we know how it works, right? And those are good reasons, but if you're using it mainly to store JSON, wrong tool for the job, right? Sometimes it's also the complete reverse, right? We're all techies. We get super excited about technology and new frameworks. .NET Aspire, anyone? And what happens is that we're like, oh my God, but wouldn't it be cool? Everyone and their mother is using it. Let's just do this, right? And as much as I get excited about technology, I've come to realize that we need to be a little bit more careful, especially if we're looking at systems that are already running, right? Another angle is knowledge building. We just assume that we're going to learn whatever is needed to make that work. We just take it for granted. We don't even consider the impact on our team, on our velocity, when we introduce frameworks like this. But finally, another trap that we tend to fall into is that we actually want to solve problems that have already been solved before. Because how hard could it be, right? But then we're actually struggling with maybe some technical things that are actually derailing us from the reason that we're here to begin with, solving business problems, right? And to actually mitigate that, we need to start thinking a lot more outside the box. Now, I really used to hate this statement. When someone would say, Laila, think outside the box, I'm like, well, thank you. How do I do that? Like, where is my box? How do I even know where the boundaries of my box are? Like, how do you do such a thing? But guess what? Every one of you in this room has actually, at least at some point, been perfectly able to think outside the box. Because the best example that I can think of is children. And I will prove that to you with a real-life story. Now, I have a daughter called Nora, And a couple of years ago, she had some friends over. She must have been 4 or something at the time. So a couple of 4-year-olds having lunch, and I made them all some charcuterie sandwiches. And one of them opens up the bread, and he's like, what is this? And Nora says, oh, that's chicken. Oh, chicken meat. Oh, well, I actually always eat pork meat. And this whole conversation on meat starts. I eat pork meat, I eat chicken meat, I eat cow meat, I eat horse meat. And at some point, one of them looks up and says, so what about people meat? I mean, that's also meat, right? I mean, I stood there like, it took me a minute to recover from my sense of shock before I told her, no, this is not something that we do. This is immoral and illegal, and we're not going to do that. But if you take a step back from that statement, that is true out-of-the-box thinking for you. It's about considering options that may seem impossible, that may shock others, that maybe you've been told not to consider. And then genuinely taking a moment and asking yourself, is this a valid option? And the thing is that that's what children naturally do, right? There is no box limiting their thinking. But as we grow up and we go through our education, and our parents educate us as well, we start to learn about society's rules, okay? The laws of nature. And throughout our education, we are taught how to do things and how to not do them. Best practices, anti-patterns. Rings a bell? Now, as we then grow up, that box is basically created. Now, to be very, very clear, I am not inciting anyone to do anything immoral or illegal, okay? The reason that I chose this specific example is because I wanted to provoke that feeling of resistance, of disagreement, of deep, deep discomfort. Of shock, right? Because you will also recognize that feeling in professional settings when someone is bringing up options that are outside of your box, because not all boxes are created equally, right? Now, what I'm basically talking about is convergent and divergent thinking, right? Where divergent thinking is happening outside the box, is more creative and a little bit more exploratory. And the idea is that we want to do a little bit of both. But how do we then do this, right? We've lost this skill over the years. And I really believe that it starts with something beyond the skill, and that is safety. Because in order to go where we haven't gone before, to come up with options that are non-obvious, it also means that we're going to have to break the rules here and there. It also is going to mean that some people will be looking at us with a weird face now and then. And for you to be able to do that, you need to know in your gut that people are not going to think that you're stupid, that people are not going to stop listening to you, and that it's not going to negatively affect your career or your reputation. And the reality is that requires a value shift in many organizations still today. And that's why we all have a responsibility to create that safety in the workplace, all of you, independent of how young you are or how experienced you are. But even more so if you find yourself in a leadership or coaching type of position. Who's in such a position? Okay, a couple of hands. So it's especially important when people bring up options to basically not have that reaction of, oh my God, that's a horrible idea, what are you talking about? Instead, say, that's an interesting idea. Can you please walk me through your thought process? Right? Basically approaching statements like these with curiosity rather than judgment. Okay? Now, assuming you're all in a safe space, and I truly, genuinely hope that you are, what techniques can we then use to basically spark all of those ideas outside the box? And I truly believe that the best technique to do this is collaboration. Now, I'm not only talking about collaboration with your peers doing, I don't know, some pairing or some code reviewing. No, I'm actually talking about inviting people with a completely different perspective than yours. People who've had a different education, who are actually, executing a different profession, maybe people from different departments, right? All of them have a very different way of looking at things and can basically then think outside your box, okay? But even if you find yourself in a case where you're like, yeah, but I'm solving a technical problem, like how do you want me to involve someone who doesn't have that perspective? I actually still think that there's value in explaining something to someone who's non-technical because it might just help you catch your own gaps. But even if you need someone who's really of a technical background, how about maybe involving the graphic designer who's kept on Figma Island? Or maybe the people that will end up supporting this application in production. Or how about the intern that started last week that you gave a task that even if they mess it up, it's going to be fine, right? All of these people have different perspective. They think about things very differently than you. And if they feel safe, right? And if you invite them and you say, really, I want your opinion, they will share it with you. They will think with you. And they might be able to actually burst a couple of bubbles in your thinking. Now, once you have that group, right, there are multiple techniques that you can use to then spark ideas. It doesn't matter which ones you use. There are even more than these available. But the idea is that we basically want to sort of unlock how our brain works. Because if you think about what happens in the brain when you have an idea, you don't just have a single idea. You actually have multiple connected ideas together, but they're still hidden away in your unconscious mind. So what we're trying to do with these techniques is actually surface them from the unconscious mind to the conscious mind, okay? Now I know this picture looks incredibly serene and happy and great, but the reality of going through this process is that it's incredibly chaotic and messy. And you might find yourself in one of these sessions completely diverging of the problem that you were trying to solve to begin with. And that's normal, because all of those connected ideas, we don't have control over them, and those are different for every individual in the group, right? So trust the process, but at the same time, make sure that you're not going too crazy. First of all, by time boxing. And second of all, by maybe inviting a facilitator, someone who's there not to contribute, but rather to say, you know, you've been going on 15 minutes about this, and that's not the problem that you're trying to solve, is it? Okay, so going through this process, we now have a wide range of possible options that we can consider, right? But now we still have to choose. And that's where we face another challenge. Our biases. Now, biases are often portrayed as a terribly negative thing, right? But if you think about how the brain actually works, it is a feature. It is not a bug. Because a bias is actually a performance optimization of the brain that enables you to make swift decisions when you need them, right? And that's really helpful when your kid falls off the swing, or you're in traffic and someone before you does something crazy. But in our context, when we are solving problems for our business stakeholders, we don't need that performance optimization. We don't need that swift thinking. We can actually take some dedicated time to think about the problem that we're trying to solve here. Okay? Now, there are over 100 cognitive biases documented, but what I want to do is actually talk to you about the top 3 that I have found are most common within the work that we do. And I'll do that by sharing another anecdote from my life, or my career, if you will. Now, at some point, I found myself in a project that I just joined, and oh my gosh, it was a big ball of mud. I mean, terrible, right? And all of this happened because there was a lot of people leaving the team, right? And then we basically were able to hire a bunch of new people, including myself, but we all introduced a lot of new frameworks and code styles, and we had these new, fresh ideas, and that led to a lot of code complexity. And because of that, we now have a big ball of mud, and we're slow. Now, what just happened in what I told you here is what is called false causality. Because I just called out multiple events in a sequence as proof that one event caused the next. There was a lot of turnover because of that. We hired new people. They introduced a lot of new frameworks and code styles. That increased the complexity, and now we have a big ball of mud. But we're just assuming that all of those events are connected without actually asking more questions. Like, was there a decent onboarding program for all of those new people that started? Did you have any documented guidelines on which frameworks to use and what code styles to apply? Did you have any documentation around how the system is supposed to work? Did they have access to business experts? Or maybe the code was already incredibly complex, but it was being managed because all of those people had figured out a way to handle that complexity. Without considering all of those factors more widely, the false causality bias is at play here. But I mean, we were stuck with this ball of mud, right? So we had to find a solution. So I remember at some point we joined the meeting, and we were all sort of discussing the friction that we were facing. And at some point, the architect of the team stood up, walked to the front, and he said, well, you know, I've been really observing what is going on over the last few weeks. I've been observing the friction that we run into, and I've been looking at the code, and there's no way back. We need a full rewrite. And with the knowledge that we have today, we're going to be able to do this. Now, what's happening here is basically authority bias, also known as the hippo effect, the highest paid person's opinion. Now, the thing is that we are looking at someone with more authority than us, with a higher paycheck than us, with a lot more experience both inside and outside the project. And they're making a blank statement like, we need a rewrite, there's no way back. So the rest of the team was like, I assume you're right. Right? And that's why it's so important, especially for leaders, to consider how their statements are affecting the rest of their team. And actually, to refrain from sharing their own opinion until everyone has had an opportunity to share their opinion and their view. And actually, you're gonna also sort of grow from that, because you will see that they come up with options that you hadn't thought about before. You'll also enable your team, because they're now able to also think through that process and learn from it. Okay? Now, at that point, we were like, no, rewrite. That's the way to go, right? So at some point, we were talking to management, and we were like, yeah, we need a rewrite. And they were like, what? A rewrite? Are you serious? It took us 5 years to get where we are. Can you prove to me that this is actually the right thing that we should be doing? Okay, we'll get you proof. And we went back and we found a bunch of blogs and articles that showed that rewrite could actually help, speed up our velocity, could help us deal with market demand more quickly and adopt, right? So we had this proof of this company and that use case. But what's happening here is the confirmation bias. Because what we basically did is go and find information that then further reinforces this belief of we need to rewrite. And we just assume that because there are so many use cases that were successful, that this is also going to apply to us, right? But is that really true? Like, those companies, were they in the same context? Did they have the same financial means? The same line of business? Did they have a stable team? Because we don't have a stable team. Did they have a stable domain? And do we? Now, the thing is that we don't even necessarily do this on purpose. It's not that we have an agenda and we're all evil. Again, this is something that is driving us from the inside, because once you truly believe something, your brain is going to make it incredibly easy to find data that further supports those beliefs. And on the other hand, it's going to make it incredibly hard to find or observe or actually look at data that actually challenges those beliefs, because that's hard and it's uncomfortable, right? And that's why it's so important to actually take some time to do that, intentionally. So I'm wondering, who of you could recognize themselves in that story at one point or another? Yeah. And that only shows how much our biases actually influence what we do on a daily basis, right? Now, if you were listening closely to this story, there is one word that came up multiple times, and that word is assumption. An assumption is something that we believe to be true to the point that we're not even going to question it. We're not even going to write it down. I mean, people breathe, right? It's obvious. But the thing is that this is exactly where we want to place those breakpoints, where we want to validate our thinking. Why do I believe this? Is this actually true? Is there any data supporting this stance? Is there someone that we could take this question to actually validate it with them, right? In short, don't assume, but rather validate, right? By asking yourself all of these questions continuously, you will start to see all of the biases that are driving all those fast and possibly faulty decisions. Okay. Now, again, this is a tricky one because biases are something that is happening unconsciously, right? It's a feature of the brain. We don't really have much control over it. So how do you then catch them when they are occurring? Well, it's not easy, but it's also not impossible. And I have 3 techniques to share with you that can help you do that. The first one is going to come across quite unexpected, and that is mindfulness. Who in the room practices mindfulness in one way or another? Whether that's knitting, walking, or, I don't know, yoga. Okay. Who's like, oh my God, seriously, mindfulness, that's just another fad? Come on, there's too many hands that didn't go up. Now keep your hand up if you enjoy building Lego. Because guess what? Lego is a mindful exercise. They even have a full page dedicated to this on their website, and they helped co-author a book on the topic. Even brushing your teeth in the morning and the evening, which I'll assume everyone does, is a mindful exercise, right? Now, we associate mindfulness with a way to deal with stress and anxiety and maybe even handle depression, right? So you might be asking yourself, what does that have to do with catching biases? Like, where's the connection? But if you start to think about what mindfulness really is, it is really nothing more than being present in the moment. And when you are truly present in the moment, you will have the ability to observe the thoughts that are coming up in your brain without necessarily engaging with them, just observing what's going on. And once you start to think about it that way, it's actually a perfect tool to debug your thoughts, right? Because then when a thought pops up, you can ask yourself, why did I think that? That's an interesting thought, right? Now, if you already practice mindfulness on a regular basis, I would tell you to try this. Give this a try. When you're looking at a problem, take some time to sit mindfully, not mindlessly, and actually think about, what is my thought process going on, right? And I hope I've made you at least a little bit curious, but if you're still like, nah, don't worry, I have other options. And the next one is actually inviting a devil's advocate. Now, who knows a devil's advocate or has one on their team? Okay, who is the devil's advocate on their team? Okay, good. Now, I would actually like to see all hands up, because I truly believe that there's value in purposefully assigning someone as the devil's advocate, right? Because we all know this devil's advocate as someone who's incredibly annoying because they keep asking all of these difficult questions and then we can't move forward, right? But if we purposefully assign someone to that role, the idea is that they're not going to participate in solving this problem. No, their job is to actually just observe the thought process that is going on in the group and catch that group thing, catch those biases when they occur and say, hey, I'm seeing something happen here. And by purposefully assigning someone, it also means that we can rotate this role, right? Someone else can do it next time. And by sharing that responsibility, there's not that annoying, terrible person on the team anymore. And on the other hand, everyone actually gets better at this. Everyone creates and generates that ability to actually think about their own thought process better. And then the final sort of technique that I can share with you is a wider sort of request for feedback, also known as RFCs or requests for comments. Has heard of that before? Okay, a couple of hands. So with this technique, what's basically going to happen is that you're going to take time and write down your thought process. All of that thinking you went through, all of the solutions that you considered, the assumptions that you made, the context that you find yourselves in, the risks that may be associated. And then you're just going to send that out to a very wide group of people and ask for their feedback. Now, because you are scaling this by writing it down and sharing it, it also means that you don't need to wait for everyone to give you feedback. You can just work with a deadline. And whoever has had the time to actually, look at it and share their feedback with you, that's good enough, right? And I know that this doesn't sound terribly exciting. You know, we don't like to write things down. We just want to code. But if you really think about it, there's a lot we can gain. First of all, did you know that people can read 2 to 3 times faster than they can actually listen to someone? Also, by having this written down, we can share it, we can change it, we can version it, we can see why we changed things, we can search it, we can refer to it at a later point. Okay? So that's a really powerful way to get some feedback as well. Now, as I'm approaching the end of the talk, there's a couple of key points that I want you to really take with you. And the first one is to slow down. Now, I understand that this really sounds incredibly scary to do in an industry that is moving so quickly, where actually those quick results are being applauded or are being rewarded. But if you start to think about how much time we lose just because we jump into things and then we're doing the wrong thing, you will actually start seeing value in actually slowing down and taking a moment to think about what you're trying to do, what you're trying to solve. Okay? Next, write things down. There's so much value in this because you will gain an unprecedented clarity in whatever you're doing. The problem statement, the solutions you considered, and all of that. There's a whole thought process going on when you're writing things down, both for yourself and your team. Also, think of all of the communication issues that we have all the time. Oh, I misunderstood you. By having it written down, we can agree on something that we can all sort of stand behind and say, and create that clarity and not have those gaps in our communication anymore. Okay? And finally, work together, collaborate. Now, if I'm being honest, it's only over the last few years where I've been collaborating with people with really, really different perspectives, different careers, different backgrounds, different types of educations. But it's been really, really enriching. Like, I've learned in ways that I really didn't expect before. So it's important that we all create that safety on the work floor so that everyone is willing and able to share their opinion. Now, we've really entered a new age with the rise of AI, and we have basically co-pilots wherever we turn around, in the browser, on our phones, and even in our IDEs. Right? And those tools can generate code more quickly than we're able to fill in that prompt, because we all know how hard that is, right? And these tools are in their infancy right now. So who's to say that within 5, 10, 15, 20 years, code might actually become a commodity? But that only makes critical thinking and our ability to debug and to pull apart our own thoughts more and more important. Because we need to be able to look at the output of these tools and then make well-balanced decisions of, is this something that we want to keep? Is this something that we want to implement? And make sure that we're making the right decisions there. Even if you look at the job market today, the 3 most sought-after skills are creativity, complex problem solving, and critical thinking. Okay? So this is really, really important. Now, as you're here at the conference, learn from all of these amazing speakers and experts that we have available here. Soak up everything that they're telling you, right? Write some of those things down so you don't forget them. Go back and share them with your peers and collaborate. Enrich your thoughts and your knowledge in your toolbox. And then when it's time for you to go and solve a problem, make sure that you are basically picking apart your own thoughts, that you debug your thinking so that you make the right choice. Now, this is the end. As always, I have additional resources for you if you're like, I want to read up a little bit more and get more understanding. I'm also going to be here throughout the entire conference. Come talk to me. I'd be happy to speak to you, listen to your problems and how you deal with those. You can probably find me at particular softwares booth, or if you just find me walking around, feel free to stop me. Thanks a lot for listening.